Behave yourself, Jaws. Good day, everyone. Today's video is all about deviating from a gem faceting diagram. Here's the scenario. Suppose a lady has a favorite ring. It's an emerald ring. Somehow, the emerald comes out of the ring and is lost. She very much wants to replace the stone with another emerald. Now, emerald, being an expensive gemstone, is virtually always cut into a shape and size that maximizes yield. The cutters want to waste as little emerald in the cutting process as possible. So natural emerald gemstones are often not cut to a calibrated size. And the emerald in our scenario was not cut to a calibrated size either. If you look at the gem faceting diagram here, which was created for beryl, and emerald is part of the beryl family, along with aquamarine, morganite, heliodor, goshenite, and bixbyite. This diagram is set up to take advantage of the unique refractive index of beryl, which is between 1.564 and 1.596. So in other words, if this diagram is used on beryl, light will pass through the top of the stone, hit a facet in the bottom of the stone, and be reflected back out the top of a stone into your eyes with a sparkle. This is called brilliance. This diagram will cut a stone with a 1.33 length to width ratio. This means that if this stone is 6 millimeters long, it will be 4.5 millimeters wide. 6 divided by 1.33 ratio. So, a calibrated emerald shaped cut using the diagram would be 6 by 4.5 millimeters. But I just told you that because of the high value of emerald rough, emeralds are cut to maximize yield, not to meet a calibrated size. This brings us back to our scenario. The lady with the emerald ring that she loves, the natural emerald in that ring was of high quality and measured a length and width of 6.16 millimeters by 5.69 millimeters. That is a length to width ratio of 1.08. Now, there's a large database of gem faceting diagrams at facetdiagrams.org. If you wanted to find a diagram and cut a calibrated size gemstone using a length to width ratio of 1.330, you would simply go to search, select emerald as the shape, put 1.330 in the L to W box, and search. When I did this, 44 gem faceting diagrams popped up. Now here's a tip. Before you search for a gem faceting diagram on facetdiagrams.org, select only show open diagrams with GemCAD ASC files and cutting instructions. This is because when gem cut designers publish their design onto the database at facetdiagrams.org, the gem cut designer can either publish the cutting instructions with his/her design, or they can decide to not make the instructions available to the public and not release them. Since you can't cut a gemstone without these instructions, I always check this box to weed out those designs that I can't cut anyway. I personally am very grateful to the many gem cut designers out there who took the time to create a really great design and then release the design into the public domain for other gem cutters like myself, who either don't have the talent or don't want to design gem cuts. We want to cut gems. Again, thank you very much for those designers that make their cuts available. So it's easy to find a gem faceting diagram to cut for a length to width ratio of 1.330. What about in our example here, where the length to width ratio is 1.08? I found one design available for a length to width ratio of 1.330. 1.083. But it's not a step cut. So how do you get the design you want? In this case, a traditional emerald step cut design with a unique length to width ratio. Well, you could design your own gem cut or facet diagram. If you do, and you add it to the fastenersdiagrams.org database, please consider releasing the instructions with the diagram for the benefit of all gem cutters. If you want to design your own gem cuts, I would recommend you go to gemcad.com. Robert Strickland has a program, GemCAD, and you can use this to design gem faceting diagrams. Here's a tip. GemCAD can be used for free on a trial basis for 30 days. So if you are so inclined, give it a try. And Robert has a number of videos on YouTube to walk you through how to use this software. Also, Robert can often be found in Tucson at the annual gem shows and regularly offers beginners, intermediates, and advanced classes on his software while in Tucson. But what if you don't want to spend time to design a gem faceting diagram for just this one stone? Well, fortunately, if the shape of the cut is an emerald or rectangular shape, you're in luck. You can just adjust the length to width on the fly as you cut, and it will not affect the final look of the stone as long as it's a step cut. If you're using a square, round, or many other gem design shapes, you won't be able to adjust the length to width ratio at all. But for a rectangular cut, no problem. If, for example, you were cutting a marquee, an oval, or a pear-shaped diagram, and you don't get the length to width ratio exactly correct, your girdle will most likely look like the Rocky Mountains. On a round or a square design, the length to width ratio is 1.00, which means the length equals the width. You can't adjust the ratio at all anyway. It's always 1.0. So if your round stone is 8 millimeters long, it's also going to be 8 millimeters wide. Again, it's a circle. Same with the square cut. Length to width ratio is always 1.0. The length equals the width. But for a rectangular or emerald cut, you can adjust the length to width ratio and not have any issues. Again, as long as it's a step cut. Look again at our emerald gem faceting diagram with a length to width ratio of 1.330. The width of this stone is established by cutting instruction number 1 under pavilion, also shown with the number 1 in the drawing of the stone. You cut the girdle, the part of the gemstone that separates the top part of the stone, the crown, from the bottom part of the stone, the pavilion, at 90 degrees. So you set a 90-degree angle, and you use the 96 and 48 tooth of your 96 gear index. The second cutting instruction under the pavilion is where you set the length of your gemstone. In this case, you set your protractor at 90 degrees again, and you cut the girdle using the 24 tooth and the 72 tooth of your 96 gear index. This will allow you to set whatever length and width that you want to give you whatever length to width ratio you want, such as 1.08. Then you simply follow the remaining instructions from your gem faceting diagram, and voila, you will cut your stone to the length and width that you need. Because emerald rough is generally cut to save rough or maximize yield, that's the reason you see so many emeralds cut in a rectangular step cut design. In fact, over time, the rectangular cut became known as the emerald cut. And this is because you can adjust the length to width ratio on the fly. So now you know the secret of the emerald cut. For this scenario, I used emerald that was created in a lab by the great Chatham family. I previously did another video on cutting Chatham Emerald. So rather than restating all the information about Chatham Emeralds, I will provide the link and you can go to that video. The bottom line is that a created emerald, like the Chatham Emeralds, are emeralds. The only difference is that they were created in a laboratory and not in nature. So I'm using Chatham Emerald rough to cut the replacement stone for our customer. For our Chatham Emerald, we need it to be 6.18 by 5.69, about 6.2 by 5.7. I've got it set in the dop set in the index, and what I do is I put a level, this is precision level, on top of a flat disc to make sure that I've got at 96 index, I've got it flat and that's this is the long side and this is the short side, although it's almost square. So that'll make sure I lose the least amount of rough. And it's not that I'm worried about losing rough, it's that I have to get it 6.2 by 5.7, and if I set it wrong in our machine, I could end up cutting so that there's not enough left to make the right dimensions. Okay, so for our emerald, we're going to set the width and the length. We want the length to be 6.18 millimeters and the width to be 5.69 millimeters. So I'm using a 320 diamond grit topper on top of my ceramic lap that I use as a master lap or base for it. So we're going to set our width of our emerald. We want it to be 5.69 carats or millimeters when we're done. So right now it's about 8. So we'll trim it down a little bit. And the opposite of our 96 tooth is the 48 tooth. So we want to take an equal amount off of there. Okay, let's see where we're at. Still got a ways to go. So what we'll do is we'll continue to trim to preform both of our 96 tooth and the 48 tooth, which is going to set the width side of our stone. And then we're going to cut the 24 tooth and the opposite, the 72 tooth, and cut the length and set the length of our stone. Because again, we want 6.18 by 5.69 millimeters when we're done. So we'll just continue to rough it, to work the rough and to preform it. Okay, we just finished pre-polishing our emerald with 14,000 diamond grit on a bat lap, and now we're going to polish it with cerium oxide and going to use our Ultra lap. So we have a master lap down, put some water on the lap, a few drops. That will hold the Ultra lap in place. Ultra lap has cerium oxide on the dull side. Shiny side goes down, dull side up. And you run the water on top. So after we take our stone off the transfer jig and remove the dop that we used for the pavilion, we want to reset the dop and the stone into our spindle for our machine. So we want the long side at 90 degrees with a 96 index tooth. So the way we do that is we set the index angle at 90 degrees, and we put our flattest disc and this flat piece of metal, and we run the index down until the stone is just touching. Set the dop into our spindle. Now we have our flattest disc, and we have a piece of very flat metal that comes from Ultra Tec. And what you do is you set the long side going this way, and you just run the machine down until it's just touching. You'll see it's just touching when the dial in, the angle starts to move. That's when it's touching this piece of metal. And you check to see that it's perfectly flush. That your girdle is just touching that piece of metal. And then you set with your Allen wrench, you set the set screw, and then you're ready to cut the top half or the crown of the stone. So we've gone around our emerald with a 600 preform 600 diamond grit to preform the crown. Now I'll use a 1200 grit. Now I'll use a 1200 crystallite disc, 1200 grit diamond, and then I'll use the bat laps, the 3000, the 8000, probably the 14,000, and then I'll touch it up with, finish it off with cerium oxide on a Ultra Lap, and then we'll be done. We'll be ready to cut the table. Okay, I finished polishing our emerald cut emerald. I went from the 8000 grit bat lap to cerium oxide. I didn't do a 14,000 grit bat lap on this one. Didn't need it. Took a great polish. Now I'll set it up to cut the crown. So to cut the crown, what we want to do is take off our cerium oxide Ultra Lap. We leave our master lap flattest lap that we got on. We'll set our dial indicator to 45 degrees. We'll remove the set screw right here. And remove the dop stick. We'll set the index gear at 96, although you don't need to, I just do that. Take the little brass set screw and put it right there in your Ultra Lap so you don't lose it. Take your table adapter. This just keeps it, make sure you're flat on the table. You put your table adapter into the spindle at a 45 degree angle, and you have everything set, everything's flat, 45 degrees. You tighten up the table adapter, the set screws in that. Remove your flat table aligner and put your dop stick in. Set the screw in, and you are ready to cut the girdle, cut the crown, the table, I'm sorry. We're now ready to cut the table. So we don't need to cut much, so I'll start with a 1200 and then move to the bat lap 3000, 8000, and then polish it with cerium oxide. Okay, we finished polishing the table of our rectangle shaped emerald. It's all done. We're going to put it in acetone and then weigh it, ship it, and send it to BOPIE'S so she can get it into the replacement for the lady who lost hers or broke the original one. So in this video I have shown that you do not need to worry about the length to width ratio when using a rectangular or emerald step cut design. I have revealed to you the secret of the emerald step cut design. Now you know why emerald or rectangular step cut designs are the most commonly used design for all the emerald gemstones being sold in jewelry stores around the globe. I hope you found the information on this video useful. Thank you everyone, and may your facets always meet. Happy faceting everyone.